From the values of a, b, c that we have found in part 1 of the question, fx is expressed in this form. We are supposed to show that this is going to have a gradient that is always positive. So let's try to find out what is f prime x. F prime x is going to be 3x squared minus 3 over 2 multiplied by 2x plus 3 over 2. So this is going to be 3x squared minus away 3x plus 3 over 2. We need to find a way to express this again so that we can discuss the fact that this is going to be always positive. And I guess one of the best way for us to re-express this is to try to change it via the completing square into another expression, and hopefully through that expression we can discuss about whether this is always positive or not. So to do that, let's make sure that the coefficient of x squared is always going to be positive 1. Let's factorize out 3. This will give me a x squared minus x plus 1 over 2. Let's complete the square for this. So it will be x minus half square minus away half square plus half. So this is going to be 3 of x minus half square, then plus 1 quarter. Or if you feel like multiplying this in, it is going to be 3x minus half square plus 3 over 4. And since we know that x minus half square is going to be bigger or equal to 0, so if I were to multiply this by 3 and plus 3 over 4, we know that this is going to be bigger than 0 for all real values of x. That is why from here we can deduce that f prime x is going to be bigger than 0 for all real values of x. That is why the gradient of the curve is always positive. This we have proven, and we are supposed to explain why fx is equal to 0. That means if I were to let this be equal to 0, it is going to have only one real root. And to do that, what we can do is by looking at the fact that f prime x is bigger than 0, we can deduce that fx is going to be a graph that is strictly increasing. If it is a graph that is strictly increasing, that means this graph can only cut the x-axis or the line y is equal to 0 at only one point. And that is why this is going to form for us the root of this equation. There's only one particular value here. So this implies that when I have the equation fx is equal to 0, there's going to be only one real root. And if I were to try to solve this using my graphing calculator, this real root here is going to be minus 1.33.